Our objectives for today's lesson are to be able to identify the three subatomic particles by name, charge, location, and relative mass, to be able to use the atomic number and mass number to help us determine the amounts of protons, neutrons, and electrons in neutral atoms, and to be able to use and write standard and nuclear notation for atoms. An atom is defined as the smallest particle of an element that retains its identity in a chemical reaction. Atoms are extremely, extremely tiny. They are impossible for us to see with the naked eye. However, with new technology such as scanning tunneling microscopes, we are now able to actually see atoms. Over here in the picture, these teal peaks, those each represent an iron atom. Now notice that we still can only really see the outer edges of the atom. We can't see inside, but we're getting there. There are three main subatomic particles that make up the atom. We have protons, electrons, and neutrons. So if we look at our symbols here, protons are symbolized as P+. The reason we use the plus is because protons have a positive 1 charge. The electrons are E- because they have a negative 1 charge. And neutron is N0 because neutrons are neutral, meaning they have no charge. This next column is called relative mass. We tend to use relative mass because the masses of these things are so tiny. It's a little bit easier for us to think about in terms of more usable numbers. So we use a relative mass, meaning in comparison to each other. So we see that the proton and the neutron are about the same size. We give them a relative mass of 1. However, the electron is much tinier. It is only 1/1840th the mass of a proton or a neutron. To give you a better idea of what that would look like, if we had a proton or a neutron that was the size of a bowling ball, the electron would be the size of a penny. So very large difference in size there. The last column here gives us our location. So we see that the protons and the neutrons are both in the nucleus, whereas the electrons are in something called the electron cloud that we'll talk about more in later lessons. So if all atoms are made up of protons, neutrons, and electrons, what makes the elements different from each other? Why do we have 118 different elements? Well, specifically, it is the number of protons that determines what type of element we have. So the first number we're going to look at is called the atomic number. This is the number of protons in the nucleus of an atom of an element. And so to find that, it's usually going to be at the top of your periodic table box. It might be in the top right corner, it might be in the top middle, but it's usually going to be at the top, and it's going to be a whole number. So that's going to be your atomic number. So again, the atomic number tells us the number of protons in the element, but it also tells us the number of electrons in the element as long as the atom is neutral. Remember, neutral means it has no charge. So in order for an atom to be neutral, all of its positively charged protons have to be balanced out by all of its negatively charged electrons. Another number that's important to us is called the mass number. And so your mass number is equal to your protons plus your neutrons. Remember, the mass of the electron is so tiny, it's not really going to matter. So we don't include the electrons. It's just your protons plus your neutrons. So one way that we can figure out the mass number is by looking at something called standard notation. So in standard notation, you either use the element symbol or the element name, and then you put a dash and a number. That number is your mass number. So looking at this question, how can we find the number of neutrons in this atom of nitrogen? Well, if you remember that the mass number is equal to protons plus neutrons, if I wanted to solve this for neutrons, then I would subtract over the protons. So we get that the mass number minus our protons is going to be our neutrons. Our mass number, according to our standard notation, is 14. I can look up nitrogen on the periodic table and find that his atomic number is 7, meaning he has 7 protons. So 14 minus 7 gives me 7 neutrons. In this case, our protons and our neutrons are the same. That will not always happen, so make sure you always do the subtraction. You can't just take the mass number and divide it by 2. That doesn't always work. Another notation that we use is called nuclear notation. And so in nuclear notation, you have the symbol, and then the top part is your mass number, and the bottom part is your atomic number. Let's take a look at some examples. Okay, so here I have a little chart. So we're going to fill in about 6 or 7 different things. So we have the name. We're going to do its standard notation. We're going to write the atomic number, the mass number, and then how many protons, neutrons, and electrons we have. So in our first example here, we have the name of the element, which is oxygen, and we know that we have 10 neutrons. Okay, so the first thing I'm going to do is I'm going to figure out the atomic number. So I know the name of the element is oxygen. I can go to my periodic table and find oxygen, and his atomic number is 8. So now that I know the atomic number, that will also tell me the number of protons and the number of electrons. So I can fill those in. Now, since I have the number of protons and neutrons, I can find my mass number. Remember, mass number is equal to protons plus neutrons. So 8 plus 10 gives me a mass number of 18. And then finally, the last thing we're going to do is the standard notation. So the symbol for oxygen is O, and our mass number is 18. Okay, the next one, they've given us our number of protons and our number of neutrons, and that's it. So we can fill in a couple things. First thing we're going to fill in is the atomic number, which is 33, because the atomic number is the same as the protons. So then we can also fill in the electrons, because that's going to be equal to our protons as well. Okay, next thing we can fill in is our mass number, because protons plus neutrons is our mass number of 75. Then we can now fill in our name of our element. We go to the periodic table, look up the atomic number 33, which is arsenic. And then last thing we're going to do is our standard notation. So the symbol for arsenic is AS, and our mass number is 75. Okay, last one. So we have P-31 for our standard notation and 15 protons. So since they gave us the symbol as well as the number of protons, we can figure out the element, which is phosphorus. Our atomic number is going to be 15. We can either look that up on the periodic table or remember that the protons is equal to the atomic number. That also is going to be equal to our electrons, because we're only doing neutral atoms right now. Okay, then our mass number we can get from the standard notation of 31. And then to get our neutrons, we just do mass number minus protons. So 31 minus 15 gives me 16 neutrons.